Hello students, welcome to the next chapter of class 11, which is probability. You have learned this chapter in junior classes also. So what is basically probability? Probability is the possibility of occurrence of any event, right? But what kind of events we are talking about, right? First of all, that let's say in day-to-day language, if we say it's very cloudy today, so it may rain or it might rain. That means whether we have a higher chances or lower chances of occurrence of that event, but we cannot calculate it mathematically, right? So here, when we are talking about probability in mathematics, first of all, we have to stick to those events in which the outcomes are fixed, right? So we are talking about random experiments. What is a random experiment? An experiment is which has multiple possible outcomes, right? Like if you perform a particular uh, game or experiment and we always get fixed number of outcomes, there is no chance apart from those number. Like if we talk about, like we toss one coin, right? How many number of times you toss that coin, you will either get a head or a tail. No other outcome is possible. Even you toss it 1,000 times or 5,000 times, the outcomes are fixed, right? And like if we throw one dice, the outcomes are 1, 2, 3, 4, 5, 6. Unless any dice is biased, you always get these 6 possible outcomes. How many number of times you throw the die, that doesn't matter. So such experiments in which the outcomes are always fixed, no matter how many number of times you perform it, such experiments are called random experiments, right? Now, examples of random experiment I have already told to you. This is experiment is like if we toss 2 coins here, right? You can say tossing 2 coins or tossing 1 coin twice, right? We can have head at the first and head at the second toss, or we can have head at the first and tail at the second, right? Otherwise, we can have tail at first, head at second, or tail at first and tail at second. So these are the 4 possible outcomes when we take 2 coins, right? 2 coins, or we toss 1 coin for 2 times, the sample space will be the same, right? Similarly, the sample space for throwing 1 dice is this. We write sample space by putting capital S and making a set of all the possible outcomes, right? In case we toss 3 coins in that thing, these are the possible outcomes, right? These are different arrangements in which heads can appear, tails can appear. So we have taken all the possible outcomes here, right? So these are examples of random experiments. Now let us know what is an event. Like I told you, we perform some experiment which has technically only fixed number of possible outcomes, how many times we do that experiment. Now, every possible outcome of a random experiment is called an event. So, technically, any subset E of a sample space S, like I told you, sample space in case of throwing a dice is this. So, every outcome, it's only 1, 2. You know what is a subset? Subset means we have a set having 6 different possible outcomes. How many subsets we can form? We can form 2 to the power 6. 64. Like 1, 2, 3, 4, 5, 6. Then 1, 2, 2, 3, 3, 4. So you have learned how to make subsets. So you can make, see, even if we take like 1, 3, 5. This is a subset of this. 2, 4, 6. This is a subset. 1, 4, 6. This is a subset. So any such subset can be defined as an event, right? So this event is any possibility. Like if I fix my event as what is the probability of getting an odd number, right? How many odd numbers are there? 1, 3, 5. So I can make this as my event. Then I can find the probability regarding to that event. If I say what is the probability, we have to define the event. If I take this as what is the probability of getting a prime number? How many prime numbers are there? I can make a subset 2, 3, 5. One is not a prime number, one is a unique number. So we do not consider this into prime or composite. It is a unique number. Prime numbers are 2, 3, 5. So this itself is an event, right? This way, whatever possibility we are looking for a particular outcome, that is called the event for which we will find the probability, right? Now, how many kinds of events do we have? Impossible event, sure event, simple event, and compound event, right? Let us understand what they are. The first one is impossible event. Now, why we are taking impossible, right? Let's say we have a sample space S of this. This is the sample space for throwing a one die. We get this sample space. We have numbers from 1 to 6. Now, if someone defines an event E as the number appears on the die is a multiple of 7, right? Do we have any number here which is a multiple of 7? Had it been we had 7 over here, it would have been at least one element in this event. But since there is no number which is a multiple of 7, so what do we say? This is what is a subset? Subset is 5. We just studied that event is defined as the subset of a set. 5, you know, 5 is a subset of every set. So in this case particularly, event is 5. Event is multiple, getting a multiple of 7, which does not occur here. So that means the very first subset, which is 5, is the event. So the probability for this will be 0 because there is no such event which is belonging to, there is no such number which satisfy this condition. So that is why it is called impossible event. Probabilities of impossible events is always 0 because they cannot occur. They cannot happen. These are those events which cannot occur. So we consider their probabilities to be 0. These are called impossible events. Next one is sure event. Now sure is something which is bound to happen, right? That means let S be the sample space. Let this be the same sample space when we throw a die. The event which says number obtained is even, odd, and odd, right? Now what happens? We have numbers from 1 to 6. This is odd, even, odd, even, odd, even. Now what does the event says? Event says number obtained is an even or odd. Even or odd. So whatever outcome you are considering here, that number is either odd or even. We have either of the two possible outcomes. Now, the number, whatever randomly you take 3, it is odd. So it satisfies this. We have or. Or means addition. So we can choose either odd or even. So all of the numbers are either odd or even. Whatever number we choose, at least one number will be there and it will satisfy this condition. So that means whatever event we define from this sample space, this particular event is a sure event. Sure event. Because all the numbers are, see, all the numbers are odd or even. Odd or even. So that means what are the possible outcomes? 1, 2, 3, 4, 5, 6. 6 divided by 6. So the probability here becomes 1, which is 100%. I told you, this event is bound to happen. That means It will be defined the way the sample space is the subset of itself. The whole sample space E is the improper subset of S. That means we had learned about improper subset. The whole set is a subset of itself. That means when the whole set is its own subset, in that case, event is a sure event. And the probability of sure events is 1, which gives us 100%. Right? Next one is simple events. Now, what are simple events? See, let us take an example in which we toss 2 coins. So this is the sample space, head, 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 tail, tail, head, and tail, tail. Right? This every single event, like we learned here in the previous one, if we talk about even or odd, we can define our event as even number. In that case, what happens? We have to choose more than one possible outcomes, right? So this is not a simple event. Simple event is when we have individual, only one possible outcome at a time. See, every possible outcome individually forms a simple event. Event 1 is HH, HT is another simple event, TH is another simple event, and TT is, right? So in all, we had 4 different possible outcomes, and every possible outcome is a simple event in its own. When we have an event in which we have to take more than one possible outcomes, that is called compounding, right? So this is simple. When we just choose one particular outcome as the event. So if we talk about, okay, let me give one example. What is the possibility or probability of getting 2 tails? See how many outcomes we are using here. How many times 2 tails are coming at the same time? It is only 1, right? Only 1. Here we have HH, HD, TH. So 2 tails is a simple event. Because when we write the possible events here, we have only one event. This is a simple event, right? If I talk about what is the probability of getting one head, can you see how many times one head is occurring? Here we have HH, HT, TH. In both these events, HT, TH. For this particular event, we have used 2 possible outcomes. So it is not a simple event. See, event is defined. Event is one thing only, like it is one head. It is asking for what is the probability of getting one head. So this is the event defined. But how many possible outcomes are satisfying this particular condition? There are 2 possible outcomes in which we have only one head. So when we write more than one events here, it is not simple. We should only have one possible outcome, right? Next one is the compound event, right? Now, what is compound event? I just told you that when out of a particular sample space, an event is defined, and we have to write more than one possible outcomes to satisfy that event. That is called a compound event, right? Take an example. If an event has more than one sample point, it is called compound event. Experiment is tossing a coin thrice, right? We toss one coin for 3 times. So the possible, what is the sample space here? We will be getting H, 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 T, H, T, H, T, H, H. and finally T, T, T. This is the sample space. We have 2 to the power 3. There are 3 coins, 2 to the power 3, 8 possible outcomes. This is the sample space. Now, if we define event E as exactly one head appeared. So out of this sample space, see how many times only one head is there. Here we have 3, 2, 2, 2, 1. TTH, head is only one time. Here also THT, the order is different, but still head is only for one time. Here also we have this. So these are HTT, THT and TTH. These are, out of these 8, we have used 3 possible outcomes which satisfy this event. So this event will not be a simple event, it will be a compound event, right? Similarly, at least one head appear. At least one head. That means minimum one head has to be there. It may be 2 or whatever maximum number is. Maximum number of heads we can have is 3. So at least one means minimum 1. That means we can have 2. Maximum we can have 3. So you can see there all these possible outcomes have at least one head. Here we have one head. In these 3 we have 2 heads. In this we have 3. So out of 8 we can use 7. This is also a compound. And the last is at most one head appeared. At most means maximum is 1. So what is the minimum number? There might be no head at all, right? So at most means 1 is the maximum. So choose at least 1. 1, 2, 3. All these are satisfying this definition, at most 1. So 1 will be there and numbers less than 1 head. That means there is no head, this one. So these 4 possible outcomes we have listed here. So this is also a compound event, right? So now these were the 4 different kind of events that we have learned. The rest of the topics, like what are different kinds of operations we can perform on these events, we will do in the next video. I hope you liked watching this video. Do leave your comments and suggestions if you have. And if you plan to take up my classes, do contact me through Urban. Thank you.